Tonight, the Pacific Ocean is running a fever. Along the equator, a tongue of water hotter than anything seen in 9 years is spreading east, and it's growing faster than almost anyone predicted. Could this become one of the strongest El Niño events ever recorded? To understand what's happening, start with the wind. In a normal year, trade winds blow steadily westward, piling warm water near Asia and pulling cold, deep water up along South America. Rain follows the warm water. Every few years, those winds falter. The warm pool slides back east, the cold upwelling shuts down, and the largest ocean on Earth changes shape. That's El Niño. Below the surface, a boundary called the thermocline separates warm water from cold. When it tilts, heat that was hiding underwater spreads across the surface, and the atmosphere above begins to respond. So what does the latest forecast actually say? As of July, the key monitoring zone, Niño 3.4, is running about 2.1 degrees Celsius above normal. That's not a projection. That's a measurement. And only 3 events since 1950 have peaked beyond 2 degrees. Columbia University's forecast plume now gives El Niño essentially a 100% chance of lasting into early 2027. 23 of 26 models point to a very strong event at the October to December peak. NOAA's own forecasters put those odds lower, around 63%. These are forecasts, not guarantees. And here's the part headlines usually skip: a stronger event does not mean identical impacts everywhere. Strength loads the dice. It doesn't write the script. Still, the pattern has a history. In past strong events, winter storms shifted toward California and the southern United States, while Australia, Indonesia, and parts of the tropical Indian Ocean turned hot and dry. Peru and Ecuador braced for floods, and the Atlantic hurricane season often went quiet. For the Indian subcontinent, the monsoon is the headline risk. This June, rainfall came in roughly 40% below normal, and India's weather department now expects a below normal season, with about a 60% chance of genuine deficiency. Weaker rains ripple into harvests, food prices, and rural incomes. The ocean feels it too. Warm water pushes fish stocks deeper and further south, straining fisheries. Coral reefs face bleaching level heat. And when harvests wobble on 3 continents at once, commodity markets notice. So why can't scientists simply tell us what will happen? Because El Niño is only one player. Timing matters. Location matters. And the atmosphere doesn't always follow the ocean's lead. That's why an armada of instruments is watching, buoys strung across the equatorial Pacific, weather balloons, satellites reading the sea surface, and computer models rerun every single month. They've been surprised before. In 2014, a widely predicted major El Niño simply failed to couple with the atmosphere, and fizzled. The forecasters remember. Over the coming months, watch 3 numbers: the sea surface temperature in Niño 3.4, the strength of the trade winds, and the heat stored beneath the surface. If all 3 keep climbing through September, this event enters historic territory. The signal is becoming stronger. The exact consequences are still being written. If you want evidence-based climate stories as the data updates, subscribe. The Pacific isn't finished yet.